Today I'm going to try to summarize a work which has been done during the last 1 year and a half by two groups which have been mandated by their organism. One is a CNRS, and which is the main fundamental research organism in France, and the French Space Agency. And in these two groups, we had a lot of people involved, where the names are indicated at the bottom of my slides. So had the chance to be in both groups. So I'm very happy to share some of the results we obtained at the end of this exercise. So just as a reminder, I'm going to start with the context of this presentation. So in France, every 5 years, we have what we call prospective exercises. And so they are led by the main French research organism. They are not necessarily the same year. For example, atmosphere science or geophysics, internal geophysics, they don't start their prospective exercise the same year than astrophysics, but every 5 years they have to do that. And this exercise have for aim to determine the major scientific priorities that the French community is supposed to lead during the next 5 years, taking into account, if possible, the financial, the human resources, geopolitical context, and new environmental context. Sorry. So what the mileage I'm going to show you in these studies are for the French situation, of course, but even if it may vary for other countries, the conclusions apply to all. So as I said, in 2023-2024, we had two prospective exercise led by the CNES, so which is the French Space Agency, covering all scientific fields from Earth to universe, and which was, of course, based mainly on looking at space infrastructures. And we have the astrophysics division of the Earth and Universe Institute, which depend from the CNRS, Centre National de la Recherche Scientifique, which is, as I said earlier, our main fundamental research organism. And in that case, we focused more on ground infrastructures. We have different groups working in different parts for this perspective. There is science, of course, but there is a group more focused on human resource, on funding, on structure of our research. And new this year, we have also a group which was dedicated to looking at the carbon footprint, the ecological transition corresponding to our activities. So we worked during a year. We met almost every week in two of these groups. So it was quite a lot of work. And in the case of CNRS, we based our work essentially on community surveys, interviews with laboratory directors, scientific councils in various fields in France, like our Sun Earth program. Some people important at INSU level or even Ministry of Research level. But all of these people obviously linked to astrophysics. On the CNES side, as the French Space Agency has also a lot of links with other partners like companies, we had interviews with a wide range of players in the space industry, laboratories, of course, but also companies like Thales, Airbus, as well as IPCC members, sociologists, and students. So the scope of our work was to obtain some recommendations and scenarios based on French government directives. I will come back to that a bit later. The work was based on scientific studies and the work we led in the groups during the past year. If we want to be consistent, we should look at the impact on all planetary boundaries like biodiversity, but it was difficult because it's not always easy quantifiable in this context. So we had to reduce our scope to greenhouse gas emission and mainly carbon footprint of our different work science. So just as a reminder, and I think it's probably, I hope, evident for everybody now, climate change is starting to become a societal challenge. And of course, as we have been seeing that last week in Spain, really a very big emergency. So if we see the global climate change, we see that the consequences will be tremendous in the next 10 or 20 years. So, of course, as scientists, we have strong responsibility toward future generations. And so, as CNRS has said in its ethics committee, we also have to take the environment and these changes as an integral part of research ethics. And so that's one of the reasons why we had, for the first time, such a group for the exercise of perspective at the CNRS level. I'm not going to comment a lot these pictures because I'm sure you have seen them already. On the bottom left, we see that depending on the trajectory of carbon emission we will have in the future, people starting born today or born in 20 years or born 20 years ago, they will not have the same climate as we have today, of course. And so it could be a very strong change, especially if the carbon footprint is very high in the next 20 or 30 years. And of course, climate change has a lot of impact on a lot of things on the Earth's surface, like drought, biodiversity, etc. And so, of course, it will potentially change a lot of things in our way of living with respect to today or yesterday. So why these groups? Because we have a societal and institutional imperative. In fact, the French government issued a strategy for low carbon. And a lot of our main research organizations, CNES and CNRS are some of them, have made the commitment to indeed reduce by 40% their carbon emission by 2030, so less than 6 years now, in order to obtain carbon neutrality by 2050. What does it mean with the figure you have on the bottom left? Is that you need to pass from 445 megatons to 80 megatons in 2050, which is a very strong decrease. You see here that it means we need to reduce by around 7% our carbon emission per year. If we exclude farming, because farming was considered like being difficult to reduce simply because it's a way to feed people. So it's in French, I'm sorry. If you want details of what correspond each of the color, I can tell you afterwards. But what you see is green is transport, and this is the one we will probably have to reduce the most. So with this 7% reduction per year, we will reach minus 35% by 2030. But it means that we need to start now, not in 3 or 4 years. And indeed, that's where it's the problem. If you look at few results which have been obtained by the scientific community for this specific prospective exercise or for scientific study run in parallel by other scientists, you see that we are really not on the right track. So on the left, this is a paper by Convenors et al. In 2024, where he looked at the carbon footprint of the different facilities in astrophysics blue and violet are for space, and green are for ground. So we definitely see that blue and violet are mainly the most important emitter. And what we see mainly also is, of course, the beginning of the space race in the 60s, which was very, very important. We had a reduction between 1980 and 2010. And again, we are starting to re-augment our carbon footprint when we are supposed to reduce it, which is a very important issue, which is mainly related to new space. On the right, you have the carbon footprint of French astrophysics laboratories, which have been calculated during this exercise. And you see that, in fact, infrastructures, which are in blue, you have ESA, the European Space Observatory, European Southern Observatory, etc. So also ground infrastructure come for 2/3 of the carbon footprint of the laboratories. So that's very important to take this into account. You can't just take your carbon footprint only of your laboratory itself with purchase, traveling, because it's not enough. You need to take into account the fact that all the scientists, they are using ground or space infrastructures, which add to their carbon footprint. And the conclusion is that per year, if we exclude people working in administration, engineers, we see that our carbon footprint for an astronomer is 63 ton CO2 equivalent per year, where for European people, we should be at 2 per year. So it's huge. And unfortunately, if we are supposed to reduce, we are really not on the right track. What I'll show you here is how the carbon footprint of astrophysics in France is going to evolve in the next 15 years, taking into account all the new infrastructures which will start in the next few years, so square kilometer array, CTA, etc. And so we should be reducing, and we are increasing. So clearly we have a problem here that we need to tackle at some point. And one important result is that eco-design cannot reduce impact by more than 20%, meaning that even if we do eco-design for our next infrastructures, it's not going to solve the problem either. So I need to quicken a bit. So the main findings of the Space Agency exercise. So we looked, in fact, at the carbon footprint of different scenarios of satellite or constellations. So I'm not going to enter into the details of all these 13 configuration of satellites. What I want to focus on is 6, which is a nanosatellite, 8, which is a constellation around the Earth, and 11, which is a very big mission with a collaboration with America, for example, where it's a more large mission, like, for example, Solar Orbiter or Athena. And so we see here that, of course, the carbon footprint of a CubeSat is very small with respect to the other type of missions. And what also we see is that what is very important in terms of carbon footprint is, of course, launch, but also all the part which is called AET, AEV, which is all the integration of the instruments, the tests, which are made in clean room, etc. And so we need to take this into account as well. So now if we try to look at how this carbon footprint can be given per kilogram with respect to the mass of the satellite, of course, we see that it's going to be very small for CubeSat, and it's going to be bigger for a large mission. But you also need to take into account the fact that a mission, a CubeSat, will probably last only 2 years, while a very large mission will probably last 15 or 20 years in space. So once you have launched it, we need also to take into account the fact that the exploitation period need to be as long as possible. That's not going to be very easy with a CubeSat. And there is also the risk of a rebound effect. If you launch a very small satellite, it's of course less expensive, so you would like to launch a lot. So in fact, you have the opposite effect of what you want, is to reduce your carbon footprint. Because if you launch 100 CubeSat, then it becomes to be a problem as well. So of course, we have a lot of other results in our document, but had to focus on a few. For the main recommendation of this French Space Agency transition group, we recommend to annually quantify these GHG emissions of the entire French scientific space segment and set and honor a global reduction trajectory for these emissions with the target of -7% per year, which is going to be tricky. And we also set that the carbon budget for emissions should be imposed from all stakeholders. And of course, we need to select the missions within the limit of this trajectory, which is probably also a very tricky point. Of course, to do that, we need to raise awareness and train all stakeholders in environmental transition. And after, when we are exploiting, we need to optimize existing mission operating time, better use of scientific data, share and limit ground infrastructure, and of course, reuse, recycle, and co-design. And the most important thing is probably to promote cooperation, share data, and reduce competition between countries or between continents. If we pass to the main result of the CNRS exercise, so we first try to interview each laboratory directors in astrophysics. So we have about 18 main astrophysics laboratories in France. 16 accepted to discuss with us, and they agree that their role was to be aware and commit and have actions to try to tackle this problem. But in fact, the level of commitment is not always the same depending on the people you speak with, which is probably the main concern. It can be, okay, we are concerned, but we don't want to do anything, to convince, but for now we can't do much because we lack directive guidelines coming from INSU and CNRS headquarters. So you have the notes. You see that majority of the lab are not for being convinced of strong action and start to do something, but it's really still very limited to reduce this carbon footprint. What we did also is to discuss with the community via a survey online. We had 300 respondents, which is not so bad. But what we don't know is who responded. And so maybe these people who responded to who answered our survey were probably already committed to the cause. So of course, the results are quite good. So I show here 3 of the main questions we asked. Knowing that 70% of GHG emissions are due to research infrastructures, I support the notion of reducing the number of instrumental projects. 76% were okay or very okay. If we don't make our ecological transition now, it will be imposed on us later and not in the way we would like. And here we have 85% which agree with that. And we can continue to carry out high-quality research competitive at the highest level with the least environmental impact. And we had 83% okay or almost okay. So we see that we have the impression that the community, at least, is aware of all this problem and is okay to start doing something. Have a lot of recommendations here. I'm not sure I have the time to go to all of them. We can come back to them if we have time. I think the most important one is my first bullet, making strong programmatic choices. Science and measured scientific questions should be at the heart of our choices, scientific choices. And we should evaluate scientific efficiency, considering sustainable development criteria. And check, of course, human resource and budget to build and operate the current projects. Because, of course, today, we have a lot of projects and not always the people to exploit the data of all the research infrastructure. It's a very important problem in France. And so this means that we need to reduce it anyway, whatever the carbon footprint. And we need to avoid instrumental duplication by strengthening collaboration between countries and agencies. So we have the same recommendation than the Space French Agency. And of course, we need to significantly increase the scientific return, support efficient and rapid scientific exploitation, overcome the logic of productivism and carbon emission linked to publications, international conference, multiplication of instruments. And the next point is measuring and raising awareness. So again, GHG assessment, like we proposed in the French Space Agency group, and reduce, of course, at the lab level, but also at the research infrastructure level. And finally, try to spread strong message. There is no planet B. We need to give rational perception of space and don't think that we will install people on the moon or Mars next year, etc., etc. And what is probably the most tricky one is influence international choices in order to reduce research infrastructure, not at the French level, but at a global level. And that's it for me. So reduce the impact of our activities by rethinking the notion of scientific and social progress. We need to overcome our fears of scientific dropping out. We need to act now and act decisively. We need to revise our software at all levels while restoring meaning to our commitment as researchers. To achieve this, we need to make strong, well-funded scientific choices, doing much better with less impact, setting an example to restore meaning for science and the entire society. And I'm going to stop now. I'm just giving you the links for the reports. They are in French for now, I'm sorry. We hope to translate them for beginning of 2025. Sorry, I was a bit long.
Thank you very much, Aurélie. Thank you.